This next guy is a little bit more complicated, and what we're going to do is we're going to use our calculator in order to help us solve. So your calculator can also create a sequence for you, and so we're going to look at how we can use that to help us. So it says the least number of terms. We want to find the least number of terms that must be added to the series to obtain a sum greater than 100. Okay, well, it's asking about sum. So I know I'm dealing with S sub n equals n over 2 times u sub 1 plus u sub n. And it specifically says that we want this sum to be greater than 100. We want this sum to be greater than 100, which means our monster guy is going to eat the sum and not 100. Well, this is the exact same sequence as we had above. And we created a equation for that, but we'll rewrite some of it. We've got u sub n. We know that u sub 1 is negative 10 plus n minus 1 times our common difference, which is 4. We don't know what n is. We actually specifically want the least number of terms. We want to know how many terms. So we know that n is equal to question mark. We know what u sub 1 is. It's negative 10. But we don't know what u sub n is. But we do have an expression that we can use to represent u sub n. This is going to end up being a system of equations. So this guy's a little difficult. So let's talk about what we're going to do here. What we're going to do is we're going to try and fill out this sum formula with all of the information we possibly can. We don't have n, so I'm going to leave n over 2. U sub 1 is negative 10 plus, and then I don't have u sub n, but because I don't want to have multiple, I don't want to write u sub n again. It feels like I haven't really done anything, right? I just plugged in negative 10, and the idea is like, well, then what next? What else do I do? So the thought is, well, can I plug in anything else for u sub n? What happens if I plug in this guy for u sub n? Because they are interchangeable, like a puzzle piece. Well, instead of u sub n, I would plug in negative 10 plus n minus 1 times 4. Lots of parentheses going on there. Okay. And this needs to be greater than 100. So there's a lot of things going on, but realize that what we did is we now only have one variable in this situation. It's n. It appears twice, but that's fine. But now we don't have n and u sub n in an equation. It would be hard to solve if we did. It would be impossible to solve if we did. So this is a helpful step forward. We're going to combine terms first within this parentheses. Negative 10 minus 10 plus, and I'm going to distribute that 4. That becomes 4, negative 10 minus 10 is negative 20, minus 4 is negative 24. I'm going to distribute n. I'm going to distribute n over 2 to both of these terms. So realize that the 2 divides out with this number right here. So 4 divided by 2 is 2. So that becomes 2. And then n times n is n squared. 2 divides out with this 24 to make it 12. And then that n multiplies there. So that's minus 12n. You can think of this as 4n squared over 2. And then the 4 in front of the n squared and the 2 cancel out to 2n squared. Same with 24n over 2 would simplify down to negative 12n. And it's all greater than 100. So we want this equation to end up being greater than 100. And my thought is, I have no idea what to do besides just start plugging in numbers and solving. When you feel that way, take out your calculator and go to a graph. So when we go to a graph, I'm going to graph this equation that I want to figure out how do I get to be greater than 100. So I'm going to do y equals 2, instead of n squared, I'm going to do x squared minus 12x, and then graph it. It's a parabola. We can like maybe do menu and then trace, graph trace, and I can start scrolling around and see what's going on. I'm like, okay, well, what happens if I try and get as close as possible? I'm going to keep scrolling till I get to 100. And you're scrolling for a while, but maybe you'll eventually get there. We've already scrolled past it, right? But it's hard to tell exactly where, because right, we've got like 14.1, and we know that n has to be an integer. Remember, if n represents the number of the term, right, this is our second term or our fourth term, it has to be a whole number, and our calculator doesn't help us with that. It can, though. If we press menu, we're going to create a table, and we're going to split screen table. This table shows us what is going on with this parabola. And we've got our x values here and our y values here. And it's whole integers, right? So notice at our 10th term, we're at 80, and then our 11th term is 110. So this way, you can use your table to help you step it up in order to get like just a table of values that would represent this sequence. Because we realize that, oh, well, the 10th term is 80, and the 11th term is 110. So the least number of terms that must be added to the series to obtain a sum larger than 100, this would be below 100, which means it has to be the 11th term that just barely brings us over 100. So a total of 11 terms must be added together within this series in order to at least be greater than 100. This one was really hard, but hopefully you understood this idea of we can be plugging in some equations for here. We can use our calculator to create tables of values, and rewatch it if you feel like you need more explanation or repeated explanation. Example 5 is just practicing our sigma notation. We have talked about the formula a lot. We just haven't talked about the sigma notation. So we're going to write this expression as a sum of terms and then calculate that sum of terms. When we type this into a Word document, it doesn't like to format well. And so really what that's saying is this guy, I starts at 1 to 4 of the equation 2i plus 3. Which means the sum of from the first term to the fourth term represented by this equation. So it's really like our u sub 1 plus u sub 2 plus u sub 3 plus u sub 4. We're talking about the sum of our first 4 terms. And we just need to figure out what those 4 terms are. And this is the equation that gets you there. If we replace 1 with I, we get 2 times 1 plus 3 for our first term. If we replace 2 for I to find our second term, 2 times 2 plus 3. Replace 3 for our I, and replace 4. So this would be 5 plus 7 plus 9 plus 11. I'm going to do some Gauss technique and combine a few things if I can. 9 and 11 is 20, which is nice. 5 and 7 would then be 12. So then 20 and 12 would be 32 as a total for our sum. So we first wrote it as a sum of the terms, and then we gave the answer. Then it says, hey, write this series using sigma notation. Don't solve for it. We just want to use sigma notation. So sigma, we know we're going to start with 1. First, let's count how many terms we have. 1, 2, 3, 4, 5, 6. We're going from the first term to the 6th term. Then we just need to have the formula that represents this situation. So our thought process here is, oh, okay, well then that's u sub n equals u sub 1 plus n minus 1 times d. Okay, well, u sub 1 is 1, n minus 1, d we add to every single time. 1 plus, distribute the 2. And we end up getting this as our formula. Realize that we start with I, and that means that I has to be part of our formula, not n anymore, which can be a little bit of a mind bender sometimes. But we just rewrite it as u sub I equals 2 times I minus 1. That's it. And that's the formula that goes in here. And it just describes the sequence that is the numbers that are all being added together. Okay, we've now converted it into sigma notation. That is it for our second lesson of this section of our sequences and series. We now know what a sequence and a series is, and we're going to talk about our real-world application of simple interest the next class. Good job.